treatments for patients with AIDS and may even prove to be an alternative to a vaccine against HIV. Here to explain his exciting new study and its implications is Scripps Research Institute infectious diseases professor, Dr. Michael Farzan. Dr. Farzan, thanks so much for joining us. You are the lead author of this new study. Can you tell us what your team of scientists found and developed?
Well, yes, we did two things, really. We developed a novel kind of inhibitor of HIV that has some very promising properties and has shown to be, in the laboratory, more potent and much broader than any other entry inhibitor.
That's very, very exciting. Did you engineer a new molecule or a protein to do this?
We did. But we took our clue from existing proteins that HIV needs to get into cells. So we took pieces of one of those proteins, and we added it to a piece of an antibody, and we added it to something that looks very much like a second protein that HIV needs. And the combination works much better than, well, either of the components or than any antibody.
That's very exciting. And this approach then was tested on monkeys, correct? Can you tell us what the results were?
That's right. So we combined that inhibitor with a increasingly commonly used gene therapy vector to introduce into the muscle cells of monkeys a gene that makes this protein. So now your body is manufacturing this protein. And when we did so, we were able to protect rhesus macaques from very high challenge doses of the virus.
So what is the next step in the research? How soon might human tests begin?
It's very hard to say at this point. There are three directions we need to go in both animal studies and in humans. The first is to explore the use of the inhibitor as a protein therapeutic. And this is a very easy first thing to do and easy to test in human trials, but it has the limitation that one would have to inject it every several months. The second approach is to use it as a therapeutic for individuals who are already HIV positive, using the gene therapy approach that we've used. And here the idea would be that it would allow you to lower the number of drugs that you would have to take to control the virus, in the best case, to zero. And then the third case, and the last case, would be where we use this to protect high-risk individuals from an infection. But in each step along the way, we're going to need to monitor the safety characteristics of our approach very carefully.
So clearly some research still being done, but in your career studying infectious diseases, how optimistic are you about these findings?
We think this is as close as we have gotten to something that can provide maybe near universal protection from the virus. But we still have considerable hurdles to overcome to get to where we want to be. I think we are proud of how effective it is and the fact that it neutralizes everything, including very divergent viruses that we've thrown at it. So these are two very good things, but ultimately it's going to depend on how the early human clinical trials work out.
All right. Well, good luck in the research ahead, and thank you so much for joining us today, Dr. Farzan. Congratulations on your findings so far.
Thanks so much.